Hi everyone, again welcome to this another lecture of the LPS class. Today we are going to talk about we are continue to talk about the tickle TK that we left last time. Last class or in the last lecture we saw the canvas as a widget, and we got a lot of commands as to how to play with the canvas and how to actually get people to use the canvas. We also found some of these new commands, like first of all, like the bind command that we started talking about it like a couple of weeks ago. That bind commands, and then we also associated with bind tags, because there are more than one binding for an event. So essentially, like when there is an event, whether it's a button press or a move of a mouse or whatever it is on a particular graphical user interface, we typically use the bind command to create a binding for an action. So when you actually select or put together a command using the button press, like you write all the characters and then you press run, that command gets run in the background. That is because of this binding that causes it to run, where the run command is bound to that event, or that event is actually bound to that run command. So that's something that we have seen. Now we also talked about this bind tags. Essentially, the bind tags essentially, like that determines, it's a command that determines which bindings apply to a window and the order of evaluation. So a bind command itself is creating the binding, and then the binding is associated usually with a window, a class, or all. So you can specify one of them basically. So we saw this in the previous lectures. The bind tags command actually now determine which bindings apply to the window and order of the evaluation. What does that mean? So the usage is essentially it's bind tags window followed by the tag list. So an example will be bind tags dot b is our window, and then the order that we specify is all dot button and then dot b. So when an event happens, basically like first it's applied to the all, which is like everywhere outside, plus the button, and then to the top level, then the button itself, whatever that is going on, that will be evaluated, and then finally like dot b. So this will allow you to actually, like, this multiple events can be trapped, and then they, multiple bindings can be trapped, and then they can be run, and then they don't need to be running at the same time or all simultaneously, which they follow this order by which it will be run. So this is something that I wanted to tell you, like last time we saw this bind tags, we didn't explain at that point a whole lot. Now it is there. And then the other widgets that we haven't really touched upon, but I really want you to understand and try to read upon this, is the tree widget. This is also like very common when you look at your Outlook mail or any kind of lists. Basically, like the views that are displayed are based on the tree. So the tree view widget can display and allow browsing through a hierarchy of items and show one or more attributes of each item as columns to the right of the tree. So you have like a big thing, basically you have each item which is displayed, and on the right hand side there are columns where it is displaying its attributes. So if it is a mail program, here you can say subject, from, date, to, things like that, the various fields that you can think of for a particular mail I mean you can also like say like whether it's important, priority, whatever. So for this mail you can associate all these attributes also. And then this particular widget is created by the tree view command. So here we create tree view dot tree, and dot tree is the widget. And then if you want to add anything to that tree, we just say like dot tree insert. And then rearranging items is dot tree move. Then we can detach an item from the tree, which is using dot tree detach, or even completely delete that item using dot tree delete. Then we can open widgets basically. So that is like set is open command. First we need to specify whether it is an open is true, and then set is open to open the widget. And then by opening the widget we can now add stuff into it, delete stuff, query stuff, things like that. So this is another widget that we never talked about in the previous lecture, but I just want you to know it's a useful one. So in today's lecture we will be talking about extending Tickle with C, and then some of the third party Tickle extensions, expect, BLT, and Tickle die. And then finally the future of Tickle TK. Actually this is more like the past. The past kind of determines the future. Past of Tickle TK. What are the various versions and what they did, what kind of thing, and then what is the latest version. So that's what we will cover today, and let's look at the topic. So extending Tickle. So the main philosophy that we will be talking about is to focus on the primitives, and then we will have like some basics on the interpreters and how to execute scripts, how to implement new commands, dynamic loading, managing the result string. I'm not going to talk about it today. The main thing is essentially like, I mean, this is regarding the machine level understanding as to what are the different memory pieces and where the result goes into, and how do you manage the whole results. And then we will also like look at some useful libraries like parsing variables, lists, and hash tables. So we saw this in the very early lectures of Tickle. One is usually we can write usually better to write a Tickle script rather than a C code. It's quick development and more flexible, and it is high level, so no compilation is needed. It's also like a higher level way to write the scripts. And why do we write it in C? This is something that we also like talked about earlier. We need to access the low level facilities. That is like hardware resources can be managed. Like in fact, malloc or malloc actually is a memory allocation in C that specifically goes to the heap and actually allocates the memory. We can request all those kind of different hardware features directly using C. Then there is also efficiency concerns. Basically like when we have like iterative calculations, C can, since it is a compiled language, can optimize, and hence it provides much faster execution. And then finally, if we need more structure, and then if the code is complex, say for example we are generating a program for a DNA sequencing algorithm or DNA sequencing, that entire algorithm can be coded as a C program than Tickle script. Again, this is the hypothetical and probably ideal case. You may argue even for a tickle code, which is okay. But when this code gets complex, we need to have like definite infrastructure to be in place, and for that C is better. If you have to write a new tickle command, like I mean that implementing new tickle commands that provide few simple orthogonal primitives. So it's low level to provide independent access to all the key features, but at the same time it can be high level to hide unimportant details and allow efficient implementation. So that's the reason why we can implement new tickle commands. So here quickly like a weather reports. So the goal is to retrieve weather reports over network from different servers. So if you use the tickle command set, one where we say like retrieve report, format, print on standard output, that's too high level, so it is inflexible. Now let's look at a second set of commands. We open a socket to the weather server, select a station, retrieve the first line of the report. This is too low level. So you can see that actually like we still use the same tickle command set here and here. Now consider a third command set, which is basically it returns the list of all the available stations, and given a station name, retrieve report. That's it. That's your command structure. This is just right. So we will look at how to do it with these kind of commands itself. So in this section, like I mean, so for designing a new command, we want to make sure that we need to choose the textual names for the objects. For example, dot dialog dot bottom dot OK, file3 or std in. So really like objects can be named in the textual context. If this is the case, then we have to use like hash tables to map to the C structures. Other one is essentially like we can also try to use the object oriented commands. For example, we can say like dialog bottom OK, configure foreground red. This kind of style is good for small set of small number of well defined objects. They don't pollute the namespace. Basically each one will be independent, and also like allows similar commands for different objects. So there are definitely advantages in going with object oriented commands. And then the third category is actually the action oriented command, which is string compare $x$y. This one is good if many objects or short lived objects. So again, when you design a new command, make sure that your considerations go through these three things. Now how do you format the new commands? So usually the preferred way is make them easy to parse with tickle script. So somebody else writes a tickle script, they can easily parse your command results. So for example here temp 53, high 68, low 37, precip 0.2, sky part. So this kind of thing basically now you can know that okay, this is my index and this is the value. So the current temperature is 53, highest is 68, low is 37, and amount of precipitation is 0.02, and then sky is partly cloudy, whatever it is. And make them symbolic wherever possible. Example, it's we don't want to specify just numbers alone. So these kind of in between like those things will make it easier. Now we can also use package prefixes in the command names and global variables. For example, instead of just stations, we can say with weather stations, or if the weather station is XXX, we can say like whether stations xxx underscore xxx instead of just saying like just xxx. Same weather report and then maybe play things like that. Basically like we can use the package prefixes. So this way like I mean it allows you to allows for the packages to coexist without any name clashes. Now let's talk about the interpreters. So that's the basic one, and then now the interpreters. So tickle interpreter structure. This is a structure that captures that encapsulates the execution state. What are the execution states? It has variables, the commands implemented in C, the tickle procedure, the execution stack. So it encapsulates this entire the execution states. You can have many interpreters in a single application, but usually just only one is active. So the way to create interpreter is tickle interp, use a star or asterisk interp. This basically creates the structure, and then we can just point that structure to the create command, create interp command. So once we have the structure, then we just say basically interp equal to tickle create interp, and this is just an object oriented command which now creates your interp. And then if you want to delete, use the procedure tickle delete interp terp interp. So this will delete the interpreter. And if you want to execute tickle scripts, we basically like define integer code, and then code equal to tickle eval interp set a equal to 1 or set a1. Now it evaluates this one and then sets the value of that as a code. The code typically indicates the success or failure, either it's tickle OK, normal completion, tickle error, error occurred. Another way to do it is the set a1, you can put it inside the init.tickle, and then you can say tickle eval file interp init.tickle. And there is yet another third way to do the tickle evaluation, which is interp set a1 as 3 different strings. So now the interp result points to the string, the result or an error message, and then the application will display the result or message for the user. Okay, and then where do scripts come from? Basically, you can read from the standard input, read from a script file, or associate X events and wait for the events, invoke the associated scripts with this the TK, and then embedded in the C code. This is fixed or private scripts that we'll talk about. So creating this new tickle commands essentially. So we write the command procedure in C. So EQ command client data, client data tickle interp, where we create that one basically like then we have the integer argc and char star star rv. So this is in C it is written. So if it is less than 3 or like not equal to 3, then we just say like wrong arguments. Otherwise we go and like compare the argv1 and argv2 from here, and then if they are not the same, then result is 1, otherwise result is 0. So this is basically to compare two commands to see whether it is the same or not, and then we return the return to the main. and then once we create this command procedure, then we register this with the interpreter, that is tickle create command interp eq command client data and null. So the eq command is now called eq, which is essentially a string compare command. Now once we register this, the eq command will be called whenever eq command is invoked in the interpreter. You can also be delete. You can delete the command by just giving the tickle delete command interp eq. So this is the most useful for object oriented commands, object commands. Now, so we talked about the client data. What is client data? So in the tickle command file here itself, we talked about the client data, uppercase client data, and then lowercase client data. So here we talk about it again. It is used to pass any one word value to the command procedures and callback. So the second client data is usually the pointer to the data structure manipulated by the procedure. So we pass the first one and then the second one is manipulated by the procedure. Can and then the cast pointers in and out of the client data types basically. So we can say like client data gizmo pointer, and then pointer we can define that basically like star and then the client data. So we can have many objects share one command procedure by using this. So this is how we write new commands and register new commands with the interpreter. So now let's look at the packages. So our goal is now to make it easy to develop and use tickle extensions. So we can use the package prefixes to prevent name conflicts. So this is one of the things that we talked about in the earlier one, right? In the earlier slides, we use a package prefix. So we can pick a short prefix for a package, for example, RD. So we use this in all the global names essentially. So in C procedure, it's uppercase RDB open. C variable is RDB, and then the tickle command is also like RDB underscore. So now once we have specified or use the package prefixes, now we create the package initialization procedure, and it is named after the package. So RDB underscore init is the package initialization procedure. This creates packages commands and then evaluates any startup script if we specify. So here is an example. There's int RDB init tickle interpreter int ERP. Then we create the tickle command first, create command, tickle create command, and then return tickle eval file with that, and then what the init.tickle is. Now if you want to use the package, basically we need to compile this as a shared library. So here we do the cc compile. So rdb.c, we compile that, and then we load it as rdb.o and output is rdb.so. Now we can dynamically load into the TCL shell or wish. So to load it, basically load rdb.so and then the top level which is the rdb. Now Tickle will call the rdb init to initialize the package. So this dynamic initialization is fairly new. I mean, as in the versions, we will talk about the versions of today and where Tickle and TK, what versions are there and what we should use. So now let's talk about the load command. The load has several forms: load file name, package name, load nothing, package name. Here the file name is the name of the file. Basically here you have tell it as rdb.so, so that will be the package, that will be the file name, and then the package name is the top level package specification that is inside, which is in this case it's rdb. So in this case it will be just xyz. So whether we load it as a DLL, dynamic link library, or so is we can use info shared lib extension to decide between these two. We can also use info loaded command to see what packages have been loaded into this program. If you want to load a program statically, then we specify that tickle static package is tickle interpret and character star package name. So that points to the thing, and then we also specify the tickle package init proc, which is star init proc, and then tickle package init proc star safe init proc. Once we specify this, then we can say load xyz. Of course, in this scenario, the dynamic loading is preferred. Now, the fourth option for managing results is to use library procedures. So tickle result, set result, interpreter, string. This will replace the old value. And if you say like tickle append result, then that extends the old value. And if you do append element, then it extends the old value, but now as a list. If you do use reset result, now that clears the old value. Now let's look at the utility procedures, and one of them is parsing. This is used by command procedures to parse arguments. Usually it takes in a value and a code. The code is just a tickle get int interpreter rb1 and then value. it stores the integer in value and it returns tickle OK or tickle error. If there is a parse error, then it returns the tickle error and leaves message in interpreter result. Other useful procedures, tickle get double, tickle expression double, tickle get boolean, expression long, and expression string. So the tickle get boolean accepts S, false, 1, 0, etc. And EXPR is essentially like variations interpret argument as an expression. So in utility procedures, what are variables essentially like? So basically they can be read, write, or unset. So here an example, basically like we have a character value. Value is tickle get var interpreter a something, and then tickle set var interpret something, and then unset something else. So we can use get, set, and unset. Basically, pretty much read, write, and unset. Then you can also set traces, basically. So that is you can trace a variable. So that is trace var, and then we can say okay, tickle trace reads, tickle trace writes, trace procedure, and client data. So we can trace it through how the value actually is changing throughout the program, throughout the script. So and then the trace proc is it will be called basically to during each read or write of A. So it can you can monitor the accesses, can override value, and read or the value read or written. Now for parsing, assembling proper list, we use the tickle split list and tickle merge. The hash tables are quite flexible. Basically, it is init hash table, create hash entry, find hash entry, delete hash entry, and delete the whole hash table. The hash table is just like having tickle associative arrays in C. It's also an excellent way to store the client data records for object oriented command model. And then dynamic strings is through this these procedures: dstring init, dstring append, dstring append element, dstring value, and then finally dstring field. The dynamic strings grow efficiently without bounds, like a good string class in C++. It's used internally by Tickle for result management. So this is again another data structure within Tickle. So in terms of extending Tickle, interfaces to C itself are very simple. So tickle is designed to make this true. And when we extend tickle, we focus on the primitives and use tickle script to compose fancy features. So we write the most primitive procedures first, and then we basically combine the features of tickle to combine multiple primitives into one, and then call that the larger command. So if you are writing a widget for TK, the good news is that one widget that can work on Unix, Windows, etc. So that is your best one. But so the TK port uses the port of xlib to support graphics, so it's okay. But what is the bad news is that you will have to write to xlib. So TK actually uses only xlib, which is the lowest level part of the X libraries. It doesn't use XT, Athena, Motif, etc. So to draw, you have to use the xlib also. So TK supplies utilities, for example, the 3D outline drawing, the font utilities, event notification, timers, idle procs, etc. And then you have to supply the tickle commands, the initialization procedure, configuration table, event handlers, and deletion callbacks. Then we use object oriented command paradigm, that is one tickle command per widget class and one tickle command per widget instance. Now I will talk about a couple of other meta languages or meta scripts basically. One such thing is called expect. The expect is really the scripting language to interface with FTP, Telnet, FSCK, etc., which cannot be automated. So one way to it's also a very good way to create GUIs for interactive command line applications. It's also good way to react to prompts from the command line apps, and usually they expect can automate tedious interactive processes, glue GUI actions to simulated keyboard outputs, and reattach the sub process to keyboard. And one thing to note is it works only on true POSIX or the Unix systems. So uses pseudo TTYs, basically TTYs, a Unix construct, and that's the reason why it doesn't work well in the others. So in expect, the commands are like this. Basically, there is a command called spawn. You can say basically it's telnet and which machine it is, which server, and then what is the port number. So the expect responds to patterns from pipe. For example, expect can say like connection refused, unknown host, login, default. So when connection refused, basically that means that exit. Unknown host is the DNS complaint. Then we have the login procedure. Reconnect two-way pipe to the console. So the other one is the DLT essentially. This is also it's a toolkit offering set of widgets and geometry manager. So this helps you to draw the pictures, display graphs very easily. And this particular toolkit offering is written in C, it has several mega widgets. The BLT graph is one of the sub one, and that is the most useful one, and that is the one that is very popular also. Then other commands basically like highlight text, drag and drop, bar chart, table, things like that can be easily built using the BLT. So to invoke a BLT graph widget, we specify the BLT graph command with the $G as the widget name, and then we specify all the other things. And then here we are just configuring the $G, and then we can configure the x-axis and the y-axis as to what the value should be. Here the x-axis is pretty much its time, and y-axis is not the time. So once we create the configure this, and then we create the various axes, the x-axis and the x-axis and the y-axis. We then create the elements basically. Element create series 1, x data is $x1, y data is $y1, and then what is the line width, foreground, background, and then what is the amount. Similarly, we can plot another set of data as well. So that's how the BLT graph widget is used, which is very common. Now let's look at one more thing, which is the TC tickle die. Essentially, this is usually the front end to Cobra projects. It lets tickle TK talks directly to the Cobra object. The Cobra lets objects written in different languages communicate essentially. So Cobra it's sitting in the center, and it gets the objects in various languages, and it communicates. The TK GUI is TK GUI for remote objects are easy and very powerful. TK die scripts are faster and easier than C++ code. So okay, so this is pretty much the technical aspects of it, of the tickle TK. Let's look at some of the releases and what went into the release and what is the latest and greatest release. So 7.6 and TK 4.2 was originally there, and this one has a revision of Gridder needed for Specticle FCS, C API change for channel drivers, actually the beta release and all happened, so ignore that statement there. And then 7.6 plug and 4.2 plug, which have features needed for Netscape plugin, and you can just use the plugin information. And then safety, I mean already released in plugin binaries, and no source release until Tickle 7.7 and TK 4.3, which is also like past now. So 7.3 is essentially 7.5 is the latest and greatest. Sorry, not 7.5. Basically, we will talk about that. But after 7.6, the 7.7 came into being, and TK was from 4.2. It became 4.3. Here, basically, we had native widgets on PCs and Mac. There's a new menu mechanism essentially. The menu bars are implemented with menu widgets. There's a new menu option for the top level windows. The chair of menus are clones, and it can use the same menu in several places. and hiding the pair of entries is another issue. So the new font mechanism basically, like this is very nice for non-Unix machines. Basically we specify label and then $L, I mean sorry .L and font times 12 bold, and then we say font create title family Helvetica size 24 and weight is bold, and then we label basically to title, and then font configure title and size. Size is 36. So the other things were basically virtual bindings essentially and event generation. So this is something that we didn't touch upon. The TK windows can create virtual bindings essentially, meaning like virtual events which can be bound inside. So you don't really need to do all the actions that the 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 tool is expecting. Now it also supports the standard dialog. There's the portable file commands rm, mb, make dir, and etc. It also supports the binary IO. So read write blocks of data, insert extract fields of blocks, and then copy between channels. And then other possible extensions to 7.7 and TK 4.3 are mega widgets, image revisions, and then channel support, and then finally more text improvements. So these were all the original dates essentially, but the next one is the article 8.0. This one has a bytecode compiler, and this is ftp.neosoft.com. I should have it. And then we have a new object system for data representation, a new C API for command procedures, many other TIGL library procedures. The old interface is still not supported, but it is slow. I mean it is still supported, but it is slow. And then what about the namespaces? Basically, like that is another thing that we need to worry about. Okay, so in TIGL 8.0 we also made some possible changes to the semantics. The more aggressive list syntax checking is enabled in TIGL 8.0, and then the conversion for LFN and LFN. So for the Tickle 8.0 we have the bytecode compiler essentially, and you can go to the FTP neosoft.com for the third party items. There is a new object system for the data representation, the new C APIs for command procedures and many other library procedures. So here the old interfaces are still supported, but they are very slow. And what about the namespaces? And then there is also like some changes to the semantics, a more aggressive list syntax checking, basically lappend and lindex, and then changes to the error messages, error info, and then line numbers. So the view the schedule basically like these are all like different. So the latest one is Tickle TK 8.6. Tickle supports object oriented programming. It has a stackless evaluation. So when the procedures are called and the procedures are nested, the nested procedures are called in a sequence. Previously it used to use a stack for the execution. Basically it stores all the state in a stack, and then it executes the next one, and if that also nests another procedure, it retains everything into another stack and then go on. So in the new one that particular thing has changed, basically like that that was found to be like fairly inefficient, so it is changed, and then it's a stackless execution in Tickle 8.6. It also has enhanced exception handling. The commands called try and throw, which attempts to actually catch an exception and then actually also like to change the course when then exception happens. Okay, and then there are many other enhancements to the Tickle 8.6. On the TK front, there is a built-in support for PNG format for the graphics. There is also a new command for busy windows. Essentially, it's called TK busy command. There is support for angled text and moving things on a canvas. So, and other projects basically the spec Tickle, spec Java, WebEdit, microscripting, basically like we can use we can edit web pages, just what you see is what you get kind of mode using the WebEdit. We can insert Tickle TK scripts at various places, and then the script fire at interesting times essentially. And then the safe Tickle basically, which is has a better TK, it has better TK support, the socket communication, and developing interesting security policies. You can add authentication, for example the MD5 signatures. So that's pretty much what I wanted to cover in terms of TK. So today mainly like we looked at several areas basically. So once again like I just wanted to summarize the things that we did for today. So mainly like we talked about the extending Tickle with C. We also looked at the third party Tickle extensions, the expect, PLT and Tickle die, and then we talked about the past and the future and the present of Tickle and TK, which is essentially like which versions, what are supported, what can you expect in the future. So I think this concludes this lecture. Once again, thank you very much for listening. Thank you.